Yeah, your boy Chili here. Welcome back to Nano CEF. Quick recap in the last video. We created the world's shittiest browser that only goes to YouTube. That's all you need, really. Now, we fixed some problems. Look at this. The browser supports resizing. I mean, that's a pretty advanced feature. And when you close it, it doesn't leave a bunch of zombie processes on your system. So, I mean, I think that's all in the good day's work. But we're not finished yet. We got like a list. We got a list of 3 things that we really want to accomplish here. Number 1. So ostensibly we're trying to use CEF to build a desktop application. It'd be kind of annoying if you have to host something on the internet in order to load your desktop application, and also you can't run your desktop application if you don't have internet access. That'd be kind of annoying, right? So we need a way of loading our web content off the disk instead of off of the internet. That's number 1. Number 2 is we need a way of making it not look like ass. So I mean, you can make it look like this if that's your kink, and I guess that's a aesthetic for sure. But if you're looking at something that's looks like a real application, then you probably want it to look more like this or like this. So we're gonna look at that makes it more like this and less like this. But if you like this, you can have this. Just keep it away from me, okay? So that's number 2. Don't look like ass. Number 3 is we need a way of connecting the stuff happening inside of the web app to the stuff in your C++ code. Because ostensibly the reason why you're doing this shit is because you got some stuff you need to do in C++. Otherwise, I don't know, you would probably just, at this point, you would just pull in Electron and do it all in JavaScript, as painful as that sounds. But, so if you're making a C++ app and you need a front end that doesn't look like ass, but you still need to do some stuff in C++, you're going to have to bind those 2 things together. So that's number 3. So those are 3 things that I think we're going to do in this series. So in this video, we're going to do number 1, which is loading stuff from your disk instead of from an HTTP server. Now before we do that, let me just do a quick little review here. I did some cleanup off screen. So I pulled in, the Nano CEF, the injected types, these 2 types into their own file. All the stuff with the window. We have 2 functions, create browser window and clean up browser windows. That's all nice in here. And now our win main is very clean. You're doing 3 things. You're calling CEF execute process, you're calling CEF initialize, and you're creating your browser window. And then you just run your message loop and everyone's happy. So that's all just nicely in here, cleaned up, ready to go for step 1 of our new features. So I mean, the idea here is instead of putting in a URL to an HTTP server to download files, you're going to want to put a path to something that's on your disk. That would be nice, but it doesn't really work. So what we need to do is we need to give our Nano CEF a way of loading stuff from the disk instead of a server. So how we do that? Well, pretty much the way you customize anything about CEF is you use these 2 bad boys to inject handlers that override the default behavior. So here we have the lifespan handler, and that's how we got the pointer to the browser that we could use to do stuff with the window. And in the app, we are going to, if we go to this type, CEF app, we can see the things that are injectable from this thing. It has a function to get resource bundle handler, get browser process handler, get render process handler. And then we get it to return our own custom implementations of these handlers, and those handlers will customize the behavior. So what we want in this case is the CEF browser process handler. And we're going to do our standard practice. Instead of creating a separate class that is inheriting from browser process, we'll just make Nano CEF app also inherit from this and return a pointer to itself. So there we go. Now this class is also implementing the interface of the process handler. Now one of the virtual functions of CEF browser process handler is on context initialized. This is a little hook that is called after some initialization happens, and it is at this point in time that we want to inject something that will load files from the disk. So there's a function called CEF register scheme handler factory. So the scheme is like HTTP, HTTPS whatever. So there's something called a scheme handler factory, and you can set it per scheme and domain name combination. So we can say, wow, so when someone does a HTTP request to a special domain name called disk, not disk.com or anything, just disk, we're going to say, okay, in that case, don't use the default thing that is going to handle the request. Use our special sauce. Now the question is, we need the special sauce. So I mean, we're not done here. We're going to create the special sauce. So add a new item. We'll call it Nano File Scheme Handler Factory. There we go. Let's include CEF scheme. I don't know what the correct include is going to be, but I think this will do it. And so let's create our class. So we'll create the Nano File Scheme Handler Factory, inheriting from public CEF Scheme Handler Factory. So what does this bad boy do? Like, what is his job? It's a factory, so it doesn't do something per se. It makes a thing that does something. So what we're going to do in here is we're going to register for this combination of scheme and domain, use this factory. And what the factory is going to do is it's going to say, okay, for every request, I'm going to give you a handler to use for that request. And so the function that we're overriding that is going to be called for every resource that is requested is to create. It says, hey, create me a resource handler for this resource. And it gives you information about it, like what's the request. And you can use this information to determine which handler you want to create to handle it. But in our case, we're always going to use the same handler. It's just going to be one handler that handles stuff that you load from the disk. But we need to make that handler. We make the factory that's going to return the handler. We need to make the actual goddamn handler. So I don't know, call it like Nano CEF File Resource Handler. Probably include CEF Resource Handler in there. All right, so this is the thing that's actually going to be loading the file from the disk. And there's a bunch of functions that's called on it, you know, as the browser is accessing the file. So the first thing it's going to call is it's going to call open to open the request. Now, if this were like a normal request to a server, this request is going to come in and it's going to start with a header, and then there's going to be the content. And so there's a function here to get the response headers from that request. Now we're loading as a file, so there's no header per se, but we're going to simulate one because that's what the browser wants to see. And finally, there's a function here to read some data out of the response to the request. And this could be called multiple times until all of it has been read. So we implement these three ones and we should be good to go. Now we're going to need, because this is a process that is going to go over multiple function calls, we need to maintain some state. So if we're going to be loading a file, we're probably going to need fstream. And let's also include string. So std if stream file stream. So the file that we're going to open up, size t for file size, I guess. Seems good. We'll initialize that to 0. And we're going to save the part of the file name, the extension part of it, because that will be useful for us. You'll see why in a second, but let's add our little special sauce that we add to all of our CEF types, which is to implement ref counting. And don't forget to put the correct class name in there. We need one of those in here as well, just while we're at it. All right, so here's the data. Let's get on it. So what we need to do is we need to take the information in this request and use that to load a file from the disk. We're going to assume right now that the files exist just, you know, the paths are relative to the working directory of the executable. And that'll be fine for our purposes, at least for right now. Now let me just put a little comment in here. So this little table, beautiful ASCII art table, is expressing a little bit of a complicated part of the open function. It has two return signals that determine, you know, what the outside world is going to do with this information. So there's the actual return value of the function, but there's also a reference to a bool, not a const reference, indicating that we're probably going to set this one. And the combination of these two, the truth table, you got 4 combinations, and they determine what's happening here. So if handle request is true, that means basically the action is taken immediately. But you could also defer the action and, you know, do things a little more asynchronously, because there's a lot of asynchronous programming that is supported in Chrome, because, you know, it's a pretty serious piece of software. So you need async in there, obviously. We want to do things immediately because we're not getting fancy with it. So that means that we are going to set handle request to true, and we are going to return true. Now you could also set handle request to true and return false, and that means I just cancel that shit. I just say, no, we're not doing that one. Deal with it. When you can't have that file. And that might be something you want to do at some point, but for right now, we're just always going to return true and true. So now we need to parse the URL. And that's annoying. Luckily, CEF gives us some stuff to parse it for us. So if we include CEF parser, we should be able to just parse that bad boy. CEF URL parts. We call CEF parse URL. We get the request. P request, because that's my fetish. Get URL. So we can get lots of stuff from the request. One of the most important parts is the URL. And then we will plug that into URL parts. That is not what I wanted you to do. Yeah. We'll do it live. That is not what I wanted you to do either. There we go. Okay, so now we have parsed the URL into its constituent parts. The path. So we create a CEF string. Again, this weirdness with CEF string. We give it a pointer to URL parts.path, the path part of the URL, to string. Yeah, so we convert that to a string. We use that to create our path. We get a relative path from that. That's going to strip out the leading slash, I think. All right, why are you angry? Probably because I didn't include file system, I would imagine. More happy? Yes. Relative path. There we go. So there's our path. So if we're going to the URL, let's give ourselves a little goal to work towards. So we want to do http disk/index.html. So this will give us this part of it, just index.html. Now we also want to get the file size because we're going to have to report that in the response header. So let's just use std file system to get the size of that file. Another thing that we're going to report in the response header is the extension. So let's grab the extension from the C++ path object. Now the problem with this is that I believe it includes the dot from C++, and we don't want the dot. We can just do some string fuckery to get rid of that. And if that is not empty, if the extension is not empty, wait a minute, we're going to use CEF get mime type to convert the extension to a mime type. But I named this file extension. We need a mime type Pokemon here. There we go. All right. So we figure out, do we know of a mime type that matches the extension? If so, that's the one we're going to use. And finally, we can open our mfin file. File stream is equal to std if stream given a path. Open it as binary. Do not do anything with the new lines and the whatnots. And now we return true or false to say whether we handled the request or cancel. And what we'll say is that if we somehow failed to open the file, then file stream will be false, convert to bool false. So we'll just return that and we'll say blah, blah, blah. Of course, if this fails, it'll throw an exception and then it'll just blow everything up. But I don't really care at this point. If you did care, you would, wrap it in or try a catch. But we're not about this. This is a small program. Small programs do not do error checking. All right, get response headers. Okay, so we got to tell, okay, here's the stuff that goes in the header. So CEF response, we get a pointer to the CEF response object. And there's basically three things that we want to set in here. First, if we have a mime type, put that in the response. I don't know if it matters that much, but it's always nice to have, I suppose. Secondly, I guess we got to set the status to 200 to say that it was okay. Thirdly, the response length should be file size. So this is int64t. So we might as well say that this one is int64t. And then, I don't know, int64t, I guess. There you go. Make it all match up. That should be good. So those are the three things that we set in the response header. And now we actually tell it, okay, let's read some data. So the way that read works is, the Chrome system at some point is going to call read to get the actual content out of the file. It's going to give us a pointer to a buffer. We fill that buffer with this many bytes maximum. Don't do more. You could do less. That's why there's this bytes read reference to tell how many were actually put into the buffer. And then there's a callback, because of course you could do all this stuff asynchronously. So you could say, hey, I didn't fill it yet, but I'll call this function when it's full, and then you can figure it out. And we're not going to do that, so we ignore this one. But we can't ignore these ones. We got to use them. So the first thing I guess we could do, I don't know if this is necessary for our case since we're not really checking errors, but I mean, if they give us a null pointer in the buffer, we can't do much. So we return false. And when you return false, the bytes read number, this is a signal. So you can set it to like a negative number, and -2 means error. I don't know if we'll ever hit this code path, but I guess we put it in there. We might as well. Now the next thing we're going to do is, okay, we're going to try to read this many bytes from the stream into our buffer. So we cast the buffer to a car pointer. I don't know why it doesn't come in as a car pointer anyways, but okay. And then we read that many. We call read with this many bytes, and it will read up to this many bytes. But it might not read that many if there are fewer. If there are fewer, it will only read as many as there are. So we got to check to see, okay, so how many did you actually read? Luckily, streams have a little function called gcount, which tells you how many bytes were read in the last operation. I know it's self-explanatory. The naming is just so pristine. Who names these things? I don't know. But anyways, we'll set bytes read to that because that's how many bytes we read. And now the return value, if we read any bytes, the return value is going to be true. However, what's going to happen here is it's going to call us. And let's say the buffer is big enough to hold as many bytes as we need. So we're going to read all the bytes into the buffer. And we're going to say we read, 69 bytes. And then we return true. It's going to get those bytes. It's going to call us again. We're going to say, there's no more bytes to read. We read 0. And then we're going to return false with 0. And that means end of file. No problem. No error. We're done. So that's how you signal. The signaling in these things is a little fucky, let me tell you. Because it's like a whole bunch of combinations of out parameters and like Boolean values. So I'm not a fan of it, but it is what it is. It's CEF's world and we just live in it. So that's it. So that should be everything. This should be enough to read files from the disk. Now we have our Nano file resource handler. So our factory is going to include Nano file resource handler, and it is going to return a new Nano file resource handler whenever a resource is requested. Are you angry? Okay. So it says we have to override. There is a pure virtual function cancel that we have not overridden. So I was aware of its existence. I thought maybe it had a default implementation that just did nothing, but apparently no. Void cancel override. It does exist, and we just do nothing because if the operation is canceled, that's fine. When they destroy this object, eventually the handler object, the file will be closed and everyone will be happy. If you were doing asynchronous operations, you would probably have stuff to cancel the operation, maybe. I don't know. But in any case, we don't do anything special. If you cancel it, then you just cancel it. It's fine. Nobody cares. And now this one is no longer an abstract class, so we can create it with new and return it. And anytime they're using this factory, we will always return the file resource handler. So it's a very simple implementation here. We don't inspect the request or anything. It's your one-stop shop. And then in Nano CEF app, we include our scheme handler factory, and we say, okay, so for this combination of scheme and domain, don't use the default factory. Use the special sauce. Nano file scheme handler factory. Use that. And there you go. And so when we call this function, it'll put this object in a little lookup table. And whenever it sees this combination, it's going to use this one to create the handlers for every resource that is loaded from this combination, which is the combination that we're using here. So Bob should be your uncle, right? And that's it. You didn't have to change anything in the Win main or anything in the browser window besides the URL. You just inject it through the app. The app is your entry point, your little thread to pull on. Now, when we run this bad boy, the working directory is going to be the outdir. So let's go to the outdir. We're going to create a little file in there, index.html, because that's what we're requesting. And just a very minimal HTML document here. Put some text on the screen and do a little styling, just a little inline styling for you. All right, moment of truth. First we try to build. We see if we missed anything. We did not. And then we run. And we get an exception. Ah, lovely. What we wanted to see. All right, let's check the call stack. Where are we at? File system. Yeah, that makes sense. That's what we were doing. File size. Open. Okay, it's having trouble here. It's having trouble with the file size. What is your problem? Well, let's look. Path. Oh, it's trying to load favicon.ico. Ah, I didn't say load that. I said load index. I don't have a reference to that in here, but the funny thing about the browser, it's happy. It's very helpful like that. It will try to request things that you didn't even want it to request. I didn't tell you to do that, but it's just say I'm going to do it anyways. So it's going to try to request a favicon if you don't specify one. So what we can do, we'll give it a link. We'll say, here's the icon for you, you little son of a bitch. No, it's not a file. It's just I put the data right in the goddamn HTML, and guess what? It's empty. So there you go. Suck it. And if we do that, now we load our web page. It's beautiful. Oh my God. Oh, look at that. It's a thing of beauty. Simplicity at its core. It's all you need, really. But there you go. We're loading from the disk. Now, you might ask, you might wonder, because I wondered. I mean, we're creating something called a scheme handler factory. Let me see if I can find it here. Yeah, we're injecting our scheme handler factory to handle a scheme. So HTTP is really meant for hypertext transfer protocol, and that's not what we're doing. So why don't we create our own? Like, why don't we create a scheme, and we'll call it like donkey, and then that's even more explicit that we have our own special scheme. Now the problem with that is that if you have to then register that scheme in a different place, and it's annoying. Whereas if you use an existing scheme like HTTP or HTTPS, then you only have to do it here, which is easier. And it's not, you're not losing anything because there is no HTTP disk. Not like there's probably disk.com or something, but there's no just disk. So it's not like you're shadowing a real domain that you might want to load at some point. No. So this is fine. It's just, it's a little hacky, but in the interest of writing less code, this is better. But there you have it. Let me just get rid of this. We don't need this anymore. Probably. I don't know. That's it. It's not a ton of code, but you have to know where the right spot is to jam it in. That's the tricky part. That's the part that requires expertise. That's the little added value that I'm giving you here. I'm giving you a little shortcut there. This is how you do it. So we can knock number 1 off the list. We can now load stuff from the disk. It'll probably work for other kinds of files too. We'll see. Number 2 is going to be a little bit of a bigger problem, because to make it not look like ass means that we have to use some stuff that's kind of annoying, like one of these kind of things. But the beauty of these things is that if you use one of these things, you don't have to build it yourself, and you might save, I don't know, 1,000 hours off your life. I mean, that's not nothing. I'll take it. But we'll see. We'll see. We'll go through it together. You make your own decisions. Until then, thanks for watching. Hope you enjoyed the video. If you did, please click the like button. It helps a lot. And I will see you again with some more Nano CEF.